Okay, my name's Arian Khan and I'm going to solve the interview questions, the performance task. So the first question we have here is balancing the chemical equation. We're going to represent the coefficient for each molecule as x1, x2, x3, and x4. Then we're going to give each element a relationship. So for iron, we're going to, since there's two oxygens for x1, it's going to be 2x1 equals x3 because there's one iron for x3. Then oxygen is 3x1 minus 3x1 plus x2 equals 2x4 because there's 3 oxygen here, 1 oxygen for x2 and 2 oxygens for x4. And carbon is just x2 equals x4 because there's 1 and 1. Then we're going to make them equal 0 so it can help us, it'll help us put them in the matrices easily. X1 will represent the first column, x2 second, x3 third, and x4 the fourth one. So to solve the matrices, there's 4 steps, I'm pretty sure. So the first step is multiplying the first row by 3 and subtracting the second row, which is also multiplied by 2, which will change the second row and give us this. Then we're gonna multiply the third row by 2 and add it to the second row, which is gonna change the third row. Then we're gonna subtract the second row by the third row, which will change the second row and give us another 0 here. And then multiply the first row by 3 and subtract it by the third row, which will give us, which will change the first row and give us 6, 0, 0, and negative 2. So since there's 2 zeros in each row, we were able to solve them. We can bring it back into this form, since it would be 6x1 minus 2x4 by the rows and columns. And then to make it easier, we're just going to divide the first one by 6, the second one by negative 2, and the third one by negative 3. So it's just 1 and 1, 1. And since there is no fourth column, we're going to have x4 equal as t. So just be a constant. So it can, like these equations will end up equaling this, like x1 equals 1 over 3 times t, x2 equals t, and x3 equals 2 over t. And that works because x2 over here says x2 equals x4, and if x4 is t, then x2 also equals t. So then you can basically sub anything in for t. So if let's say if we do 1 for t, then x1 will be 1 over 3 and x3 will be 2 over 3. But since we don't want fractions, the best way is to make t equal 3. So then x1 will be 1 and x3 will be 2, and x4 will also be 3, just what we did for x2. And when we finish it, it will give us this balanced equation. Now for the next question, or the part 2 of that question, we're going to pretty much do the exact same thing. Label x1, x2, x3, and x4 for the coefficients. Get the equations for them from the molecules, and then we're going to make them all equal 0 so we can put them in the matrices. And when we put it in, we're going to multiply the first row by 8 and subtract it by the second row. Then we're just going to change the second row. Then we're going to multiply the third row by 3 and subtract it by the fourth row, which will change the third row. Then we're going to multiply the second row by 3 and add it to the fourth row, which will change the fourth row. Then multiply the third row by 1. Multiply the first row by 3 and subtract it by the third row, which should change the first row. And then subtract the third row from the second row, which will give us this. And then multiply the third row by 5 and subtract it by the fourth row, which will leave the bottom all equaling 0 and give us 2 zeros in each thing, so we can get it to this form. So we can divide it by 3, negative 1, and negative 3, so we're left with no coefficients for the first ones. Since the fourth row is just 0, so x4 equals t, and then x2 will equal x4 if we rearrange that. Therefore, if you just sub in t, if you put anything for t, like the previous example, then for x3 it will be 1 over 3, and for x1 it will also be 1 over 3. But since we don't want fractions, then t should be 3, so x3 and x1 will equal 1. Therefore, when we balance it, it should be this 1, 3, and 1. And that should be the balanced chemical equation. Now for the second question. Okay. The second question we have here. Here's a diagram of it. There's 325.6 feet going up, and then the total distance of this is 562.6. Now to solve for the fastest speed, we're gonna let this represent x and subtract, and this distance will be the total distance subtract x. Then we're gonna, well, to find Ben's speed, it's just, or Ben's time is distance over speed. So he travels 650 feet divided by, and he goes 2 feet per second because he's on sand. And we got 650 by doing Pythagorean theorem by these two numbers. And then he's left with it takes him 325 seconds to get to the taco stand. And the second person, for this, the time it takes him is 325.6 divided by 2 because this part's on sand, plus the time it's going to take for this, which is 562.6 divided by 5 because it's on road, so he's going 5 feet per second, which will leave us with 275.32 seconds. Now to reach the fastest speed, we're going to have to do optimization. The total time equals the time on sand plus the time on road, because there will be one, it should be in between. So what we're going to do is the time on sand is basically this distance, and we can do Pythagorean theorem to figure this out, so that's basically the form, and that's divided by 2 because on sand. And then on road is just this distance, and it's divided by 5. Then we can rearrange it so it's like in this form, so it's easier to find the derivative. Then we get the derivative of that, which is, bringing the exponent down over here, making that negative, or subtracting 1 from the exponent, and then finding the derivative of what's inside the bracket, multiplying it by that. 562.6 is a constant, so that's out, and this is just negative 1 over 5. Then we're going to make it equal 0 and solve for x to get the fastest time. Then you move the 1 over 5 to the other side, multiply everything by 4 times the square root of 106,015.36 plus x squared, and then multiply the other side by, or the whole thing by 5. So it should rearrange to this. Then we're gonna square both sides so we can get rid of the square root, which will leave us with this. Then expand the 16 into both numbers, which will leave us with this, and then take the 16x squared and bring to the other side and subtract 100 by it, which will leave us 84x squared. Then we're going to divide this number by 84, which will leave us with this, and then square root that to get 142.10 feet. So that's what x is going to equal. So now since we have x, we can put it back into the first equation to figure out the total time, which is going to be over here. So we plug it in here and over here as well, which is leave us 177.63 plus 84, and that should equal 261.73 seconds, which should be the fastest time to reach the taco stand, which should be located here. Now for the second part of the question, it's where should the taco stand be, or the taco cart should be located, so that everyone can reach at the exact same time. And if it has to be on the road, the best possible or the logical way would be to put it right above them, so they all have to travel the same amount of distance, and they'll be on the same amount of, all three of them will be on sand and they're still traveling the same amount of distance, so they have the same time and they'll reach them at the same time, which will be 162.8 seconds. Okay, so that's the performance test video.